Okay, we're going to start our tour of endocrine organs or organs with the endocrine function. They're not all glands, but they all have secretory capacity. So I try not to say endocrine gland. I will probably make a mistake because they're not all glands. Some of them are, though. And you're seeing a lot of them here. Which ones do you have to know? The ones that you have to know for this set of notes are in your notes. We may add some others later, like when we do the cardiovascular system, we'll add in one for the heart and we can add in other ones later. But for right now, you focus on the ones that are in your notes. Now, remember, we are slowly and steadily working through filling in this table. And so we are going to be filling in some hypothalamus hormones and also some posterior pituitary hormones in just a second. So first off, where is the hypothalamus? That's where we're going to start. So the hypothalamus is of course up here, but if you look at a mid-sagittal section of the brain, remember in anatomy that you're like, it's just that. It's not very impressive anatomically. So here's the thalamus region, right? And this region right here is the hypothalamus. It's just behind the optic chiasm, which is right there, and the pituitary gland hangs off of it. It will have a lot to do with the pituitary gland, and we'll talk about that as we go through this video and the next one. So here's the deal, and listen to this carefully. The hypothalamus actually makes 9 hormones, but it only secretes 7 of them. The other 2, which is the 2 we're about to talk about, are made up in the hypothalamus, and then they're handed off down to the posterior pituitary for secretion. So those 2 are ADH and oxytocin. So let me introduce you to the whole hypothalamus connection to the posterior pituitary. So here's the deal. I'm going to reinforce this again in just a minute. I just want it to be the first time that you've seen it. So the hypothalamus and the pituitary have an interesting connection because although we usually refer to the pituitary gland anatomically just as the pituitary gland, it's actually 2 separate organs. The posterior pituitary is actually not glandular tissue. It's actually a white matter extension of the hypothalamus with a capillary bed at the end. So whatever is made up in the hypothalamus and released after an action potential will get dumped into the capillary bed in the posterior pituitary. So look here. So here are neurons with their cell bodies up in the hypothalamus. These are their axons, and they will release something from the axons, and then that something will get picked up into the bloodstream. So this is what your textbook means when it refers to a neurohormone. It's really just a hormone, but it's a hormone that's released by neurotransmitters. But interesting and important thing here, these 2 hormones are synthesized by the hypothalamus, but they're actually considered to be released by the posterior pituitary. So listen, they actually do not go up here with these 7. They go down here with these 2, the posterior pituitary. So I will tell you more about them when we get to the posterior pituitary, but please do know that they're made in the hypothalamus. So if you got a hypothalamus problem, you'll also have a problem with those. Okay, and they are called ADH. Again, they go in the posterior pituitary rows. ADH, also called vasopressin, and oxytocin, and I will talk about their function when I get to the posterior pituitary. But then the hypothalamus actually makes and releases 7 different hormones that you're going to have to know, but it's a different connection. So this is the hypothalamus to posterior pituitary connection. This is the hypothalamus to anterior pituitary connection. So watch here. Whatever is made up here is released in this first capillary bed, okay? That is still considered part of the hypothalamus. And then it goes through this portal vein to go to this second capillary bed, which is actually considered part of the anterior pituitary. So there are going to be 7 of the hormones that get dumped right here, and they're all going to go the same place, and we will definitely talk about that in just a second. So there are going to be 7, and these 7 hormones are going to have kind of an interesting naming convention. So I want to teach you the naming convention before we go any further. So, by the way, this is called the hypothalamus pituitary axis, the HPA axis. or the HPA. Hypothalamus pituitary axis. It's really, really important in physiology, and you will get into it in just a minute. But before we get into it, I want to teach you a little bit about the naming convention with hormones that will help you understand why they're called what they're called. So, and I'll show you this, and we'll do a whiteboard in just a second. If you see tropic or tropin, usually as a suffix, that means target. So if a hormone is called thyrotropin, it's telling you that it's going to the thyroid gland, okay? But there's also one level of removal. So let me show you this, and then I will point it out to you again when we're going through the notes. Ready? All right, so let us, okay. So if you see tropin or tropic, it means target. Okay, so the example that I just used would be thyrotropin means targets the thyroid. Good, but if you have the word releasing or inhibiting hormone, releasing or inhibiting before it, then it changes the meaning. So stick with me for just a second. So we know what thyrotropin means. And what about thyrotropin releasing hormone? This is actually one step back. So this means that you are going to cause the release of a thyrotropin, okay? So it doesn't mean it's going to the thyroid, it means it's going to cause the release of something that is going to the thyroid. So thyrotropin is targeting the thyroid. Thyrotropin releasing hormone is going to cause the release of something that's targeting the thyroid, okay? So let's do another one. Okay, so a hormone that is called a gonadotropin, where's it going? Going to gonads, right? But a hormone that is called a gonadotropin releasing hormone. This is causing the release of a gonadotropin, of something headed to the gonads. Okay? All right, so hold on to that idea, and then I'm going to show you what I mean as we are actually going through naming these hormones. All right, so remember this, and then I will reinforce it, and you're going to hate it, but then you'll be fine. Okay, so all 7 of these hormones that we are going to learn right now are going to do this same pattern. All 7 of them are released right here. And importantly, they are all going the same place. They are all going to the anterior pituitary. So all 7 of the hormones that are released from the hypothalamus are going to the anterior pituitary. They all are targeting the anterior pituitary. They are collectively called the hypophysiotropic hormones because the fancy word for pituitary is hypophysis, not hypothesis, as in I've got a good idea I haven't tested yet, hypothesis, but hypophysis. So all of these are hypophysiotropic hormones because they are all going to the hypophysis. Hypophysiotropic, targeting the anterior pituitary, targeting the pituitary. So all of these are going to go there. Okay, so now let's look at this table that I really like and I use all the time. And that is, let me make myself a little smaller. Okay, so this table right here is really going to lead us through the next couple stages. This top purple box right here is the hypothalamus, okay? That is 7 different hormones, 1, 2, 3, 4, 5, 6, 7. all released by neurons, but they're not neurotransmitters because they're dumped into the bloodstream. And then where do all 7 of these hormones go? They all go the same place, which is the anterior pituitary, which is this orange box. Okay, they're all going the same place. And then the next layer is what they do after the hormones get released from the anterior pituitary. We'll talk about that in just a second. So really what we're concentrating on is from here to here. All of these hormones are going from here to here. The other piece of information in here is the plus or the minus. So if you see a plus right here, this one is going to cause the anterior pituitary to do something, and this one is going to inhibit the anterior pituitary from doing something. Cause, 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 inhibit. Oh, don't do that. Okay. Cause. Okay, so we're going to do the names. And by the way, you can always look these names up. It's not as if you have to stop a million times to write this down, but I will try to write them down if I can get them in the space for you. So the first one we're going to look at is this one right here, GnRH. Okay, let me write down its full name for you at least once so that you can know what you're dealing with. This is gonadotropin releasing hormone. GnRH. Okay, question for you. GnRH. Where is that hormone headed? The first thing you want to say is gonads, right? But you know that every single hormone that is released from the hypothalamus goes to the anterior pituitary. So it's going to the anterior pituitary. So why is it called gonadotropin releasing hormone? Because what it's doing is it's causing the release of something that is headed to the gonads. So it's causing the release of gonadotropins, okay? GnRH, gonadotropin releasing hormone, released from the hypothalamus, heading to the anterior pituitary to cause the release of something headed to the gonads. Do you see the pattern a little bit? Let's try another one so that you can try to see this second one. So let's try this one. Okay, so TRH is the next one. This is the other one that I used as an example. This is thyrotropin releasing hormone. Okay, you know what I'm going to ask. Where is it headed? First thing you want to say is thyroid, but you know it's not going to the thyroid. It's this guy right here, right there. Okay, TRH, thyrotropin releasing hormone. It is going to the anterior pituitary to cause the release of something headed to the thyroid. Hence, thyrotropin releasing hormone. It's causing the release of a thyrotropin. Okay, kind of see it? Okay, this one's not named the same way, but we can still write it down. So let's go this one again. Okay, this one is somatostatin. Abbreviated SS sometimes, but a more common name for it is growth hormone inhibiting hormone or growth inhibiting hormone. So GHIH, let's look at the full name of GHIH. It's growth hormone inhibiting hormone. Growth hormone inhibiting hormone. So let's see what this one does. So growth hormone inhibiting hormone comes from the hypothalamus, so it's going to be headed to the anterior pituitary. And what does it do? Its name tells you what it does. It inhibits the release of growth hormone from the anterior pituitary. Growth hormone inhibiting hormone. That's what it does. Okay, let's try another one. Okay, CRH. CRH. Find it up there on the figure, and it is corticotropin releasing hormone. So let me write it out for you. Corticotropin releasing hormone. Where is it headed? Where is it going to be headed, guys? It is not headed to the cortex of anything. It is, like all of its other friends, it's going to head to the anterior pituitary, and it's going to cause the release of something that is headed to a cortex. The relevant cortex in the endocrine system is the adrenal cortex. So CRH, corticotropin releasing hormone, is going to the anterior pituitary to cause the release of something headed to the adrenal cortex. That's something you will know later. We're not learning that right this second. Okay, GHRH should be easy because we did GHIH. GHRH is this little guy right here. Let's see what it does. Oh, resume. And it is growth hormone releasing hormone. Okay, so where is it headed? Like all of its buddies coming from the hypothalamus, they're all going together to the anterior pituitary. It is right here. And what is it going to do? Well, this kind of tells you. Goes to the anterior pituitary and causes the release of growth hormone releasing hormone. Okay. Next one, dopamine. Dopamine in this instance is a hormone. It is also, we will see later in this semester, a really common neurotransmitter. And it is either called dopamine, abbreviated DA, or the other name has more endocrine information in it. And that name is PIH, which is prolactin inhibiting hormone. Let's figure out what that one does. Prolactin inhibiting hormone. Prolactin inhibiting hormone. Okay. And prolactin inhibiting hormone. And so what does that one do? It goes to the anterior pituitary, like all of its friends, and it inhibits the release of prolactin from the anterior pituitary. That's what that one does. Okay. And then this one, last one, PRH. Bet you guys can fill that one out yourself. PRH, its long name is prolactin releasing hormone. Where is it headed? Anterior pituitary. What does it do? It inhibits the release of prolactin from the anterior pituitary. Okay, is that good? So I'll write these two for you. Last one, prolactin releasing hormone. And the target for all of these hormones, what is the target? The orange box on the video. What is the target for all 7 of these hormones? All 7 of these hormones, their target is dun, 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 the anterior pituitary. Anterior pituitary. The chemical class of hormones from the hypothalamus, every one of these hypothalamus hormones except for this little guy is a peptide. Dopamine is a water-soluble amine. Okay, so what should you be able to do now? Well, you gotta like slog through the naming instead of rote memorization. But after you've slogged through the naming, you should be able to fill in the column for hormone released and abbreviation, alternate name or example when that's appropriate. If it's appropriate, it's in your notes. The major target, the target for all of them is the anterior pituitary, and the effect. And the effect is the things that I've been saying. GnRH causes the anterior pituitary to release gonadotropins. Eventually, you'll write down the name of the gonadotropins. GHIH, for instance, inhibits the release of growth hormone from the anterior pituitary. PIH inhibits the release of prolactin from the anterior pituitary. So those are the phrases I was telling you. That goes into effect. And you should be able to basically now, for the hypothalamus, fill in 7 different hormones. Not those first 2 go with the posterior pituitary. Alternate names if they exist. The chemical class, which is peptide for every single one but dopamine. The target, which is the same for all of them. Target of the hormone is the anterior pituitary. Oop, come here, you little bugger. The effect is whatever those little blurbs were I was saying, and you didn't learn any disorders for these, so you don't have to fill in that one. Okay, so you should be able to do that for all 7 of those hormones now. And we'll stop there, and then we'll pick up the pituitary.